So our project is developing a cloud-resolving Earth system model or climate change model. And cloud resolving, by that we mean we're going to resolve the key processes responsible for cloud formation in the Earth's atmosphere, as opposed to the conventional approach, which is to kind of approximate their average behavior. And a global cloud resolving Earth system model is very computationally demanding. So we really rely on a lot of computer power, exascale or pre-exascale machines like Summit, as well as algorithmic improvements. And for that, we're using a parameterization or a technique referred to as superparameterization. Earth system modeling has a lot of societal benefits. One of the most direct is related to the Earth's water cycle. And by that I mean the freshwater supplies and the frequency of floods and droughts. Those types of processes have a large economic impact on U.S. and global economies. In a cloud resolving model, we have a much more realistic portrayal of those features, more explicit portrayal of those features, and we hope to do a much better job understanding the science behind the changes in those aspects of the water cycle. Summit's been a great resource for us. We had to spend a couple of years working on software and algorithms to make use of the GPUs and benefit from GPU acceleration that Summit makes possible. But because of that, we're now able for the first time to run our global cloud resolving model for climate length simulations. And on previous architectures, we were limited to much shorter simulations like those for weather forecasts or process studies. Our goal for Exascale is to achieve the throughput with a global cloud resolving model necessary to support a wide variety of climate science studies. And this means we want the ability to run large ensembles of 100-year-long simulations and complete all that work in less than a calendar year. And we'll know we're successful in this if the approach we're working on is adopted on exascale computers by the wider DOE climate science community. So on Summit, we'll be able to run several first-of-its-kind cloud-resolving global Earth system simulations. But on Frontier, we hope to finally have the horsepower necessary to meet our exascale goals of being able to run these large ensembles of very long simulations.